All right, so in this chapter we have two new functions to know how to graph. There is a square root function. So the square root function looks like this: y equals the square root of x, or it could be f of x equals the square root of x. Either way, you can't do the square root of a negative number, right? Because we're not graphing imaginaries, this is a real number system. So none of these would have solutions, but the square root of 0 is 0, square root of 1 is 1. Square root of 2 you would need to put in your calculator, but comes out to about 1.41. The square root of 3 comes out to 1.7, I think. Yeah, 1.73. Square root of 4 is 2, square root of 9 is 3. So I just did those so you could see that you get some decimals and then also some whole numbers. But basically, you end up with this. You got 0, 0, 1, 1, 4, 2, and you have those other ones inside there too, 2 and 1.4, so maybe about there. 3 and 1.7 about there, but anyway, 9, 3. All right, so this keeps going off this way, so I want you to notice that, look at that parabola on its side, right? So basically you have a parabola on its side, so it's kind of going that pattern: 0, 0, 1, 1, 2, 4, 3, 9, and so forth. So that's what you've seen before also. All right, so your domain is everything from 0 to the right side, so 0 to infinity. And this graph can move around so that domain can change. The range is everything from 0 up, so it's also there. A max or a min. I guess you have a minimum point at the origin. Absolute maximum, I guess it's not absolute min at 0, 0. Okay, and this right side just keeps slowly rising, rising, rising. All right, x-intercept. For now, it is 0, 0, and same as that for y-intercept. Increasing intervals. Right now, this thing is increasing the whole time. So from 0 to infinity, this thing is increasing. So it's either going to be all increasing or all decreasing. Now, this graph, it could flip over. So it could flip this way over the y-axis. So then it would be decreasing. It could flip down, so then that would be decreasing, right? So there are some changes that could happen there. But for now, not decreasing. And behavior. As x is going to negative infinity, well, graph doesn't go to negative infinity, so you do not answer that one. If somebody said as x is going to 0, you could say, oh, as I come to 0, it's going to 0, but as x is going to infinity, this is going off to positive infinity. All right, so you've seen all these transformations before, so I didn't want to make a big deal out of them. So basically, let's say you have y equals the square root of x plus 2. So that's going to move your graph to the left too, right? So it's going to take it, move it left too. You still got that pattern there. Okay. Let's say you have negative square root of x minus 4. So that moves you down 4 and flips you upside down. So all those transformations that you knew before are still there. That's reflection, down, let's see, dilation. Oh, if you want to flip over the y-axis, let's do that one. So that's if you have a negative on the inside. That would turn you to the left. Okay, all right, and let's see. Oopsie. Let's do y equals, how about 2 radical x? So that's going to be a stretch, but it's going to happen in a different way. So if I plug in a 0, I get 0. If I plug in, I get a 1, but that 1 is multiplied by 2. So now it's up here at 2. If I plugged in 4, I used to get 2, but now it's multiplied by 2, so now it's 4. So it goes like that. It stretches it taller, and so you call this a vertical dilation by a factor of 2. And so remember that dilation is, makes you taller. If it's less than 1, it makes you shorter. All right, so I talked about those. And next, putting it all together. So let's go ahead and just draw these things. So let's draw the square root of x minus 3 plus 1. So that's going to move us to the right 3 and up 1. And then we have our shape. Okay. 2 radical x minus 4, so down 4. And remember, it stretches taller. And I was going to go to 4, 2, but now it's doubled here. All right, there we go, makes us taller. And over here, x plus 2, so it moves me to the left 2, but it's going to be reflection over the x-axis. So down here, oopsie, no, here. Okay, and this last one here, oh, right here. So with this one, what makes the 0 is positive 1. So 1 makes that expression 0, and I got to move up 3. So this moves to the right 1 and up 3. And it is reflected over the y-axis, so it's going to go to the left. Oh, that might be a little taller than I need it to be. All right, that's fine. All right, so let's take a look at these. Let's see. Oopsie. Ah. Let's try this blue for a while. All right, so I got y equals. So, or f of x equals. This thing moved to the right 2 and up 3, and that pattern is still 1, 1. So right 2 up 3, x minus 2 plus 3. All right, this guy here, my pattern, I got 0, 0, and there's that one. That 1, 1 is now 1, 1, 2, 3, 4. So there's going to be a 4 here, square root. It moved to the left, 1, 2, 3, 4, 5, 6. So x plus 6, and it's upside down. All right, this guy moved to the right 4, and it's flipped the other way to the left. So it's going to be 4 minus x, kind of like this guy right here. Okay, and let's check our pattern. 1, 1, 2, 4, no stretch or shrink, and it is moved down 2. And there you have it. So now we also have what's called the cube root function. So f of x equals the cube root of x. So now remember, cube roots can handle negatives. So the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1, 0, 1, and 2. And so what happens here, when you plug in a negative 8, you get negative 2. When you plug in a negative 1, you get negative 1, 0, 0, here, here, and 8, 2. So this graph starts here, and it goes, snakes up to the right. So I don't know if you remember, but if we had a cubed function, like y equals x to the third, this looks like this. It snakes up and down. And a cube root snakes side to side. These things are inverses of each other. They're like opposites in a way, but they're called inverses. All right, so just a fact to know. So my domain here, it goes left and right forever. And as it's going left, it's going down. If it's going right, it's going up. So it always goes up and down forever too. Oopsie. Max and mins, none. X-intercepts, for now it's 0, 0. And also 0, 0 here. Increasing interval, this graph is increasing the whole time it exists. And it is not decreasing at all unless it gets flipped over, and then it would decrease. In behavior, as you go left, you go down. As you go right, you go up. Okay, so same thing as before. I think, yeah, this is the last thing. We're just going to do this and not do any other graphs or anything like that. But let's say you had, I don't know, y equals cube root x plus 2 minus 5. So that thing would move to the left 2 and down 5. That would be the center. And then it would come up and snake that way. Okay, let's say we had negative cube root of x and plus 4. So up 4, but instead of starting low and coming up, it starts high and goes down. Okay, so we're not going to be too particular about the graph, but actually, you know, if I did want to make it a little bit better, I'd know that it goes through there at least, and it would kind of come like this. All right, so how about cube root x minus 1 and plus 2. So right 1 up 2. And it's coming from the left and going up. Okay, and of course it can stretch and shrink and all that stuff too, but all the same motion.